Hello all and welcome back to this video. So in this video, we are going to continue our discussion on recursion and now start with sorting algorithm which we can do using recursion. So as of now, of course, we have seen multiple sorting algorithms like bubble sort, insertion sort and selection sort and have done them iteratively as well. Now in merge sort, it's actually a recursive sorting algorithm and it is normally very fast. Now why it is fast, we are of course going to see in the upcoming modules when I'm going to teach you about time and space complexity. But in this specific video, I'm going to teach you the intuition behind merge sort, give you a skeleton code where I would like you to try, because now you know recursion properly, like we have done lots of questions. I have told how to handle arrays as well with recursion. I would like you to try and code the merge sort algorithm. Okay, so let's get started. Cool. So everyone, let us understand the basic intuition behind merge sort. It is actually based on recursion. So always remember the types on how we can break our problem in an array, right? The one which I taught you. So the problem is going to be like this only. We are going to get a list. And we have to make sure that we sort this list out. That is from increasing order from starting to end, right? Now, the idea which I apply to this particular problem is to break down this problem, or rather I would say is I can divide this particular list, right? I can divide this particular list. And now let me make two parts. So this again is a very common thing to do. We are just dividing our list and breaking it into two parts. So this can, let's say, my left part and this can be my right part. Now if you see, I have actually broken my list from a one big list to two small lists, and I want to sort these two individual lists. Right? So a perfect use case of recursion, we have actually broken down our problem and made a same problem with a smaller size. Now what I can do is I can call merge sort on this left and I can call my merge sort on this right. And I can be assured that my arrays are gonna get sorted. The reason for that is, of course, we don't question the induction hypothesis. Okay. So I'm gonna call merge sort on these individual halves and I can now be sure that my left and right half are gonna get sorted. Okay. Next, what all I have to do now is just to make sure that I am able to. So I now have two sorted lists, left and right, and I need to make a third list which is having all the elements, of these lists, right? Which is having all the elements of left and right, but in sorted order. Now the problem might seem a little familiar, right? Because we have already done this. You have already done this problem when I was teaching you about list, where I gave you an L1 and L2 and you have to return me an L3, list 3, which is having all the elements of L1 and L2 in a sorted manner, right? So that's actually the whole idea or the whole process behind merge sort. So we are dividing and conquering our list here, right? So we have divided our list and then we are trying to conquer it. We ask individual half to go and get sorted with the help of merge sort, and that will happen. And we just have to now make sure that we are merging the same properly. Okay. So let us see the same in code as well, how the skeleton will look like. So the first thing is we are going to make a merge sort L1, right? We are going to get a list. Let us pass as of now. Okay. So pay attention everyone. Now let me explain you this intuitively as well, how the same will roll out intuitively so that you always remember. Now the very first thing which you have to understand, it's of course recursive sorting algorithm and fast as compared to other sorting algorithm which we have studied, and we are going to see that. Now let us think the same intuitively as well. So let me explain you this using again the example of students in an assembly, which we have already seen, and learn our other sorting algorithm like that, right? So you will be able to connect the dots and always remember the same. That is my aim, that intuition based things actually remain with us. So I will try that using this example, you always actually remember like other sorting algorithm on what merge sort is. Now as a teacher, again we are taking the same use case. As a teacher, we have these 8 students, right? And I have to sort them. So they are standing in an assembly. I need to make sure that they are in increasing order of their height, the way it used to happen in schools or colleges, right? Now my understanding is that instead of working on these 8 students all together, what I can do is I can ask and divide this particular into half. Now I can of course ask the first half and the second half to get sorted. So I've broken down my problem from 8 to 4 and then I'm going to merge it, right? Now let us go a little bit deep down, okay, to understand what exactly is going to happen at each step. Let's say once I'm going to divide it, then we are going to actually get 2 of such groups, right? We are going to get 2 of such groups, and let me just draw a line in the middle as well, so that it is clear that these groups are separated, right? So these two groups are separated. Now again, what I'm going to do, so let me just keep on drawing these walls between them so that you don't get confused. All I'm doing is I have now separated these two groups. Okay. Now again, I'm just dividing it, right? So this is what recursion is, right? We keep on breaking down a problem. Now again, you don't have to think of this while writing the code. But for the holistic understanding, I want to make sure that you understand how it's going to roll out. Now this again is going to get broken from half, and we are going to get two groups again. Now group of 2 students each is again going to get broken, right? So we are still dividing them into half. Let me create a wall between them so you don't get confused, right? And now if you will see, what we have actually arrived at is that we have a single student, right? Single student. So from a group of 4, I have actually kind of divided them out. Now the basic idea is to merge them on, because a single student, right, a single element is always sorted. You cannot sort more of, I would say, a single element in a list. If we are getting, let's say, 5, then this is a kind of a base case, right? This is kind of base case where we cannot do more sorting on top of this. So now next part which I have to do is merge them. And while merging, I have to make sure that I now sort them in an ascending order. So when I'm going to merge them, this is exactly what's going to happen. First, this half, like these two, are going to get merged. 2 is smaller, so it's going to come in starting, and 4 is going to follow. Similarly here, 3 is smaller, so 3 and 7. Okay. So we have these two lists which are sorted. Now going to the next part, I'm going to sort these two. Okay. So at every step, I'm just solving the same problem. Okay. And that's actually what recursion is. Now, of course, the way I've taught you, you don't have to think about them, but you should have an idea that, okay, exactly how the steps are rolling out, so that you can actually make a recursion tree or visualize the same when you are doing or solving the problem. Okay. Now, because I have these two groups, finally, I'm going to merge them. Into one group. So now 2 is the smallest, going to come first. But now next while I'm going to merge them, 3 is the next one, right? So 3 is going to come here, 3 is going to come here, 4 going to go here, and 7. So now if you will see, this is one sorted group, right? This is one sorted group. In a similar manner, in a very similar manner, I'm going to get another group, okay, which is these 1, 6, 5, 8. This is also going to get sorted. And finally, when I will have two groups which are sorted, two lists which are sorted, all I have to do is just apply my merge function again correctly, and I will be all good, right? So I hope with this example, with this intuitive example and walkthrough, the overall idea about merge sort is a lot clear. I'm not on the right side. I want you to actually draw the same. That's why I kept it empty. Okay. But I hope you get the idea, the intuition. That is very, very important. Okay. Because based on that only you will be able to write the code. Now let me help you to find the skeleton, or actually write the skeleton code for the same as well. In the initial, of course, we will be having a list. Okay. So let's call it L1. Now my whole aim is to make sure that I'm able to divide my problem. So the way I'm going to divide it, it's going to be actually, I'm going to find my medium. We have already seen how we can find the medium, right? One thing to note, this time again as well, we are actually going to work with start and end. So this has already been covered. This approach has already been covered in the binary search in the last video. So please make sure you see that. I explained you how arrays problem we divide using these pointers, right? So that we can actually limit the scope. Okay. Now to find out the medium, we know the formula. So it's going to be like this. And once we have found the medium, all I have to do is I have to form two parts. First part I can say is from S to M. Second part maybe I can say is from M plus 1 to E, right? Now these are the two parts. These are now the individual parts, and let me call them left and right. Now one thing to remember here, I'm not going to make a slice or make a copy of that. That also I've taught you already, that will unnecessarily basically increase the size or the space. So I'm going to just refer to them using these indexes only: start, medium, and end. Okay. Now what's going to happen next is I have to call my merge sort on these individual elements, right everyone? So I have to call my merge sort on these individual elements, and then I can assume that I'm going to get them sorted. In place, they are going to get sorted. Okay. So I'm not creating any new list. I'm going to call my merge sort, and it's not going to replace like return me anything. It is going to do all the changes in this list itself, right? Now, finally, all the work which I have to do is just to merge them. So my merge function, which I'm going to write, my merge function, okay, it is going to take my list L1, take the starting position, take the middle, and take the end, so that it knows that, okay, which are the two parts which are sorted. Okay, again, I hope till now you are very much flexible and comfortable with this indexing of small, medium, and end. We have used the same in binary search and other places as well. So please make sure that you understand this. You could have made the copy as well, left and right, but I believe that this is better overall. Okay, because we are not creating any extra array in the memory, array or list in the memory, and of course that will be a lot better. Now let me just write the skeleton again as well, everyone, based on this understanding. So pay attention. Let's merge sort. So just one thing I would like to do. Let me just change it here only. So where I'm sending the S and the starting and the end. Okay. So let me just call this as well. So L1. Okay. Let's say some 1, 3, 5, 9, 10. Okay, I think this is sorted only. Just give me a minute. Let me make it not sorted. So just taking a normal example, we might take other one while solving, but it should be fine. Okay. Great. So anyways, whatever is the array. Now I'm going to call my merge sort. Second, yeah, merge sort. It's going to be L1, 0. And length of L1 minus 1. So I'm specifically referring to the last element. Okay. So make sure that you send this a length of L1 minus 1. Okay. If in case your merge sort just accepts a list, then of course you can create a helper function. That way I've already told you in the find indices, right? So please make sure that you're aware of that as well. We can just create a simple helper function if it just actually takes in a list. And in that helper function, we can send the start and the end. Now the very first base case, if my S is greater than equal to E, that is my size is 1, I can just return. I don't have to do anything, right? See, one thing you have to always remember, I'm doing everything in L1 only. Okay. Next is I have to find my median. So middle is going to be S plus E minus S, right? So this is what we have already done. So I'm finding just my middle, everyone. Now I have two parts, namely the left and the right. And I have to just call my merge sort on these parts. How can I call that? How can I let my merge sort know that these are the two halves? I can call merge sort L1, S and M. Similarly, I can call merge sort L1, M plus 1 and S and E, right? Now, once I have called this particular 15 and 16 line, I can actually assume, and this is something which I have taught you, you can assume that they are going to get sorted. So you don't have to fight on that. You will get this 1, 3, 10. And this you will get as 6, 9, 15 only. Okay, let me make it 16, 9, 15. So at this point, your L1 will actually be changed something like this. 1, 3, 10 and 9, 15, 16. So your L1 will actually be something like this. Now, yes, that would happen. You don't have to question that. This is something which you have actually seen a lot of time now in PMI. Once this is done, all the work which you have to now do is to just call your merge function. Okay, so you have to just call your merge function with L1, S, M and E. So that merge function, it has an idea that, okay, from where the first half is or the left part is, from where the right half is, and you can just return. And this is actually some problem which you have already done, right? So def merge L1, S, M and E. So once I get this thing, and if I write my merge function properly, something which you have already done, your merge sort is done, right? So yeah, at this point I would like you all to try this, and in the next video I'm going to discuss the solution. Just one thing, please make sure that you try to write it down. It took me, like, I remember 4 hours to code the merge sort for the very first time. Of course, I have not understood the same in so much depth. Like, I was drawing this tree and everything and not able to understand. Just remember one more thing as well. There's a small caveat where I'm taking this S, M and E this time. Okay, so my list is not in terms of L1 and L2, the way you have solved this question, but I have to make sure that I create my list either or work with this pointers of start, middle and end. Okay, so do give it a try. I'm pretty sure that you will be able to code it. We have done enough recursion, we have worked on enough list questions, and if you will be able to work on that, you will actually feel very awesome. Now I remember even after 4 hours, like when I was able to finally do it, it actually felt a lot awesome, right? It's an awesome algorithm which will give us the result very fast, something which I'm going to show you in future as well. So once you're able to code it, you will actually feel that, yeah, it's a great algorithm. Okay. So cool then everyone, let's meet in the next video where I'm gonna write the solution for you. So do give it a try, and I will make sure that I explain you properly and also show you visually that how the same can be solved. Okay. Thank you.